Let's look at these examples again and see how we can easily optimize them. And also detect when it is not possible to optimize an expression. So we can start with looking at the dominator tree, which is this. And recall, this is a set of children and the order is irrelevant. Okay, so when we come to the first vertex, we don't do anything. Here we push A0 plus B0. And that is in vertex 1. Okay, and when we come, okay, so I said this is a stack. It's a stack of hash tables. When we come to a new vertex in this dominated tree traversal that we do during translation to SSA form, then we create a new hash table. When we come here, we also create a new one, but I don't draw it there. And when we come to this expression, we rename the operands so that we have A0 plus B0. And then we look in this stack of the hash tables to see if we can find a version of the expression with the correct versions of the operands. So we must be able to search this stack and look at each in each hash table in sequence. Okay, so we start looking in its own hash table. There is nothing, so we look at the next and we come to this expression, and then we can replace this instruction with something which uses C0 instead. Okay, then we come to vertex 4, and well, we do the same, and we will find this expression again. Vertex 3, nothing happens. When we leave a vertex, we pop the stack of hash tables. So we remove the hash table that we pushed. And then when we come to vertex 1, at the end of vertex 1, I mean after visiting its children, we will pop this and remove it. Okay, so again, we push A0 plus B0, and we find it there in exactly the same way, of course. Then when we come to the second add here, we see that it's a different version of the operands, so we will push, well, it will look like this, A0 plus B0 from vertex 1, and then we will push A2 plus B0 in vertex 4. Then we will remove this one and instead go here and push A1 plus B0 in vertex 3, remove it, and eventually remove that one also. Okay, when we come to vertex 2, we will push A0 plus B0. Then when we are finished with vertex 2, there is no child in the dominator tree, so we will remove this hash table, and then eventually we will come to vertex 4, and we will not find this occurrence of A plus B since it does not dominate this occurrence, and therefore this is very nice. I'm sure you agree. Okay, so what should we do with the rename function? When we come to a new vertex, we enter a new scope in a hash table. That means basically creating a new hash table and push it on a stack. Okay, And well, then we rename the expression as usual. And we also add the left-hand side of the instruction to this list that should be popped later when we leave W. Then we can simplify this expression. For instance, if it's, well, we can simplify it somehow, possibly. Okay, then we search the stack of hash tables and see if we can find the instruction with the same operator and same operands. I mean, same versions of the operands. And if we found it, then we push the left-hand side of the found expression onto the rename stack. Otherwise, we do it the normal thing and push a new version, and then we install this this instruction in the hash table. Okay, we continue, and we pop everything that we pushed and remove this hash table that was on the top. That means exit the scope that we entered when we came to the vertex. So this is a very nice optimization that we can do during translation to SSA form.